There are a handful of discussion topics that the Australian strategic community, whether that's enthusiasts online or the professionals in and out of uniform, seems entirely unwilling to leave alone. The big one right now, of course, is AUKUS and whether we should be acquiring nuclear submarines, but there are plenty of other examples. Another popular one right now is whether Australia should look into acquiring the B-21 Raider. In the past, debates about the value of the F-35 or a fourth Hobart-class destroyer were perennial. But through all of these, one topic has stuck around longer and continues to see more digital ink spilled than just about any other. Whether Australia should get back into the fixed-wing carrier aviation game that it exited with the retirement of HMAS Melbourne in 1982. There are solid arguments on both sides, and this video isn't really about going through them in detail. To massively oversimplify the debate, the key points of the pro-carrier aviation side, beyond the obvious offensive capabilities that an Australian CSG would offer, are that organic overwatch expands the radar horizon of the fleet enormously to allow for the early detection of inbound missiles, as well as allowing hostile air assets to be eliminated before they pose a threat, either as shooters themselves or as airborne sensors, facilitating a weapons-grade lock on a task force from outside of that task force's weapons range. On the other side of the debate, the arguments are also pretty solid. The RAN's only potentially suitable assets are the Canberra-class LHDs, which, apart from already serving a fairly important role as amphibious vessels, would also need extensive and probably pretty costly upgrades before they could operate as fixed-wing carriers. Combine that with the cost of the actual air wing of F-35Bs, and the exercise gets pretty expensive. So expensive, in fact, that it would inevitably come at the cost of more valuable capabilities and probably can't be financially justified. I don't really know which side is right, and I suspect that a properly informed debate is probably impossible without details from the government and ADF, which aren't forthcoming. Certainly with the crimp on the budget from AUKUS, the general purpose frigates, and other announced expenditure, the government's probably unlikely to want to spend the billions of dollars it would require just to buy the air wing, let alone modify the ships or maybe even buy new ones. Moreover, given that it wasn't a recommendation of the recent Defence Strategic Review to get back into the carrier aviation game, we can at least tentatively assume that the case in favour is not quite as compelling as it may seem from the outside once all the details are laid out, since, given the prominence of the debate, it seems impossible to imagine that it wasn't at least considered by the reviewers. So that leaves us with a bit of a quandary. Naval aviation is unquestionably a very useful capability, but it's one that Australia seems like it can't afford. We need, therefore, to find a way of getting the benefits of naval aviation without paying all of the costs. And, well, you've seen the title of this video, so there's no point pretending that I'm holding you in some kind of suspense. I think that the answer to that quandary is the MQ-9B Sea Guardian. The baseline MQ-9, the Reaper, will be familiar to most as the follow-on platform to the Predator, which was made infamous by the US drone strike programs during the global war on terror. These drones, more properly called remotely piloted vehicles or RPAs, fit into the medium altitude long endurance or MAIL category and are designed for persistent ISR and strike. Depending on the model and payload, they can spend up to 40 hours in the sky, being piloted by human operators connected by satellite link-up from just about anywhere in the world. Over its lifetime, the Reaper has iterated into multiple variants, each designed to do slightly different things, with the most interesting one for our purposes being the MQ-9B Sea Guardian, a variant specifically designed for maritime and littoral operations. But while this drone was designed to operate over water, it was still restricted to land-based deployment. In 2022, however, that changed, with the development of the MQ-9B STOL, or Short Takeoff and Landing variant. Essentially, this was a kit which equipped a baseline MQ-9B with folding wings, capable of getting the aircraft into the air with just 100 meters of runway, without needing a catapult or even a ski jump. Those capabilities have reshaped the MQ-9's potential applicability to the ADF, and to many nations around the world, putting fixed-wing aviation back within the grasp of just about any country that can field even a fairly small LHD. This video will go through the basic capabilities of the MQ-9B, its applicability to Australia, and demonstrate the value it could provide to the ADF as a whole and to the RAN specifically. To get the basics out of the way, the B model is 11.7 meters long and has a 24-meter wingspan versus the older model's 20. Kinematic performance suffers a little, with a disclosed service ceiling of 40,000 feet and a maximum speed of 210 knots, or 390 kilometers per hour, versus the MQ-9's 260 knots and 50,000 feet. However, the newer model improves in almost every other way, with greater range, endurance exceeding 30 hours, an increase from 7 to 9 hardpoints for weapons and sensors, and greater payload capacity of just over 2.5 tons. Note, however, that these figures are for the conventional version of the drone, and some sacrifices may have been required for the short takeoff and landing version. The sensors on the platform are variable, designed to be easily customizable depending on the mission, what the company calls bolt-on, bolt-off. But a key improvement over earlier models is the integration of an AESA radar, specifically the Leonardo Seaspray 7500 EV2 in a centerline pod. The radar offers a variety of modes, including inverse synthetic aperture radar that is designed to operate with Maritime Automatic Identification System, or AIS, to provide accurate identification of detected surface targets, at least in peacetime. It can also spot very small targets like submarine periscopes or humans in the water during search and rescue operations. Other podded sensor options include the Leonardo SAGE electronic surveillance system and potentially the Legion IRST pod, though to date this appears to have been trialled primarily on the MQ-9's jet-powered successor, the MQ-20. Other baseline sensors include the Lynx multi-mode radar and the type's standard high-definition electro-optical infrared cameras. Armaments on the MQ-9 are also much more diverse than most people realize. In the ground strike role, the Reaper can of course equip the Hellfire and Brimstone missiles that it became so linked with in Iraq and Afghanistan, but also the Paveways and JDAMs which we generally associate with manned platforms. Larger and more capable air-to-ground weapons are also possible for the class. In 2023, General Atomics released a concept showing an MQ-9B, perhaps coincidentally kitted out in RAAF livery, equipped with 4 Norwegian-made Joint Strike Missiles, a medium-range land attack cruise missile currently being acquired by the ADF, and which will be built in Australia in the coming years. And if the JSM is on the menu, that implies that the maritime strike version of the same weapon, the Naval Strike Missile, would be a relatively easy addition, given the two weapons share almost all their DNA. This would give the Sea Guardian direct naval strike capabilities in addition to its role as a spotter for other assets beyond the horizon. In addition to ground and maritime strike, the Reaper also actually offers some limited air-to-air capability, with successful testing of both the air-to-air Stinger missile and even the AIM-9X Sidewinder. Now, just because it's integrated these weapons, that doesn't make it an air superiority platform. Its low top speed, operator lag, and poor aerobatic performance firmly keep it out of that category. But even offering the ability to threaten certain kinds of airborne targets gives the Sea Guardian a potentially enormously valuable role in naval combat. Modern long-range weapons need local sensors to maintain weapons-grade locks in a kill chain. Increasingly, these sensors are being put on slow or unmaneuverable platforms, such as maritime patrol aircraft or long-endurance drones, which could potentially loiter just outside of a task force's weapons range, guiding in missiles while the ships below can't do much about it. That's not an option, however, if there's a Sidewinder-equipped MQ-9 protecting that task force. Beyond kinetic armaments, MQ-9s have also been tested with or have integrated other capabilities, including a variety of electronic warfare pods, sonobuoy launchers, and other capabilities, some of which we'll speak about in more detail later. So, with that introduction out of the way, it's hopefully becoming clear what the MQ-9B is as a platform. It's large, it's long range, it's limited in some ways, but enormously flexible in others. However, before this video gets too laudatory, I just want to take a moment to reiterate what the MQ-9B isn't. It's not a replacement for the F-35B, or for manned fixed-wing carrier aviation as a broader concept. And there are plenty of reasons for that, most of which come down to the downsides of the type, some specific to the platform, others to its class in general. So let's go through some of the negatives to set the boundaries of the capability debate before moving on to what benefits the platform can bring. First and foremost, we have to acknowledge that the glory days of these kind of drones are probably behind them. While the broader class of high-cost, high-performing, remotely piloted aircraft has definitely proved its worth, first in the global war on terror and then later in the earliest days of the Ukraine war in the guise of the Turkish Bayraktar TB2, more recently, that conflict has shown the weaknesses of these craft. Slow-moving and lacking in stealth, they're vulnerable to even fairly basic air defenses. That wasn't really a problem against the Taliban, but it's definitely an issue in modern warfare, especially naval warfare. Beyond their inherent weakness to kinetic attack, electronic warfare also needs to be taken into account. The MQ-9B, like all the MQ-9 variants to date, isn't a drone in the way that modern loyal wingman or collaborative combat aircraft like the XQ-58 Valkyrie or MQ-28 Ghostbat are. Those newer models rely on sophisticated programming and machine learning algorithms to allow them to carry out general orders as part of their mission essentially independently. A pilot tells them what to do, but doesn't really need to worry about telling them how to do it. The MQ-9B isn't like that. As mentioned before, it's more properly called a remotely piloted aircraft. An operator, probably on the ship, but potentially back in Australia, would need to be actively flying the aircraft remotely, hands-on, at all times. This makes the class inherently vulnerable to electronic warfare and jamming, because while they may have basic autopilot functions allowing them to circle in place or maybe return to base if signal is lost, they certainly can't complete a mission independently. So again, there's a vulnerability there in modern peer-on-peer conflict. Next, the kinetic performance of the MQ-9B is very lacking compared with more traditional carrier aviation hot rods like the Super Hornet or even the slightly compromised STOL F-35B. Even if you ignore the inherent and unavoidable lag that a satellite-controlled aircraft has, potentially up to several crucial seconds, the drone has long, straight, skinny wings, great for slow, high-efficiency flight, but not what you'd choose for great speed or maneuverability. In fact, the commercial-grade Honeywell turboprop engine only produces a mere 671 kilowatts or 900 horsepower, which is the main reason for the limited top speed and service ceiling described earlier. Even if it were redesigned with a more powerful engine or different wings, this is still not an aircraft that's going to be dogfighting or chasing down even the slow, lumbering bombers which pose such a threat to the Australian surface fleet that they are often used to directly justify carrier aviation. And finally, cost is a major factor. Despite this video being about cheaper carrier aviation, the MQ-9B is not a cheap aircraft. Purchased through the US FMS system, it costs roughly $130 million US per platform, though, to be fair, that does include a lot more than just the drone itself. Elements including swappable sensors, ground control systems, spare parts and whatnot are also included. But it's not as though you can really use the aircraft without most of those add-ons, so it's not particularly useful to ignore them in the price tag. So, with all those weaknesses, why make the video? What can the slow, non-stealthy and vulnerable MQ-9B actually do for Australia? Actually, quite a bit. Let's go through 5 key areas where the MQ-9B could fill a gap in the ADF's capabilities and how it might be employed if acquired. The MQ-9B already has the capability to undertake maritime domain awareness and ISR. That's fundamentally what the Sea Guardian version of the drone is all about. Long-range, long-endurance missions finding and monitoring surface targets, ideally from far enough away to be out of direct danger, is pretty much the type's bread and butter. This capability has enormous utility even without short takeoff and landing capabilities, as a purely shore-based, conventional takeoff and landing asset. The drones could complement other assets like the MQ-4C Triton and the P-8 Poseidon, which are both larger and more capable, but also more expensive to operate and smaller in number than a fleet of MQ-9Bs would likely be. The cost per flight hour for a P-8 is hard to pin down, but a US DoD selected acquisition report for the type from 2015 suggested that the annual cost per annum to maintain the aircraft would be about $15.7 million US. Divide that by the estimated 677 annual flight hours from the same report, and you get roughly 23,000 US dollars per flight hour. Now, that was nearly 10 years ago, and there's every reason to assume that the cost has come down a little bit, but even the civilian Boeing 737 that the P-8 is based on costs roughly 6,000 US dollars per flight hour to operate under commercial conditions. So, however you cut it, the MQ-9 is significantly cheaper, at roughly 3,500 US per flight hour. Away from conflict, this would supplement the ADF's ability to undertake conventional peacetime missions, monitoring the nation's approaches to counteract illicit activities like illegal fishing or people smuggling, performing maritime search and rescue, monitoring foreign vessels as they transit Australian waters, assessing the impacts of natural disasters, things like that. In a conflict, land-based MQ-9s would also be able to add considerable capabilities. Most significantly, they can provide over-the-horizon targeting, tracking and shadowing hostile surface assets, and feeding target information for shore-based missile strikes. In this way, they'd be an exceptional complement to Project Land 8113 Phase 2, Army's maritime strike solution. Whether that turns out to be the HIMARS firing precision strike missiles, or the Strike Master firing NSMs, Army is going to find itself capable of shooting a lot further than it can see, and the more assets the ADF has to provide targets, the better. If we assume the short takeoff and landing variant, even shore-based, this adds significant flexibility to the ways in which these weapons could be employed. Very short runway requirements could see these drones operated from very short strips, which could be created very quickly during a theoretical island hopping campaign in maritime Southeast Asia. The USAF demonstrated this capability of dirt strip operations for the baseline MQ-9 in 2023. Combined with Army's maritime strike plans, the ADF could find itself with a very deployable pairing of a mobile, medium-range land-based anti-ship missile launcher and a long-duration fixed-wing drone which can be launched from extremely short and easy-to-create landing strips anywhere in Southeast Asia. Not to mention, in the catastrophic worst-case scenario that might see the Australian mainland threatened, the short takeoff capable MQ-9B could be operated from any number of rough strips and even highways all throughout northern Australia, making them effectively impossible to keep out of the sky just by cratering runways. Finally, as a carrier-based asset operating off the Canberras, the MQ-9B offers a means to extend the sensor range for more valuable manned platforms performing maritime strike. At RIMPAC 2024, for example, an MQ-9B demonstrated its capability to pass targeting data off to an LRASM and, more generally, to a range of US Navy aircraft and warships. This would be an exceptionally valuable capability for Australia in the maritime domain, especially as we see the integration of not only the LRASM on the P-8 in the coming months, but probably also weapons like the Block 5 Maritime Strike Tomahawk, which will soon be equipping our Hobart-class destroyers. At that same exercise, RIMPAC 2024, the MQ-9B demonstrated its capabilities as a sonobuoy dispenser. Currently, the RAN relies on one of two platforms to dispense its sonobuoys: a P-8 when one is in range, or, if one of these aircraft isn't available, the job falls to one of the embarked MH-60 Romeo Seahawk helicopters. The MH-60R can carry 25 A-size sonobuoys, while an MQ-9B may be equipped for up to 40 A-size or 80 G-size across 4 dispenser pods. And importantly, it can deploy these sensors at significantly greater speed and distance from the carrying platform than a helicopter could, allowing very large networks of sonobuoys to be established quickly. This would be a very valuable capability for an RAN which is in the middle of a massive pivot towards anti-submarine warfare. I should also note at this point that General Atomics, the MQ-9B's manufacturers, claim a role for the MQ-9B in anti-mine warfare, but there's very little information available how this capability would work. Presumably, it would use the same Airborne Laser Mine Detection System, or ALMDS, and Archerfish Mine Neutralization System, which are currently utilized by the US Navy from their helicopters. ALMDS is a LiDAR system used to detect, classify, and localize near-surface moored mines, while Archerfish is a single-shot mine neutralization system which can be used against both bottom and moored sea mines. It seems at least plausible that one or both of these systems could be operated by the Sea Guardian, but so far it's not clear if this capability has been demonstrated. But with Australia's mine warfare capacity rapidly dwindling as we retire the Huon-class vessels without a clear replacement, any capability in that area is going to be valuable. Electronic warfare is one of those areas of national capacity which is typically kept extremely quiet and tightly classified. But a few interesting elements specific to the Sea Guardian have made it out into the open source world. One such element is the Angry Kitten ALQ-167 pod. The capabilities of this pod are classified, with most articles vaguely identifying it as an AI-driven modern electronic warfare jammer pod capable of adapting automatically to whatever radar signals it encounters, and possibly even to multiple signals on multiple frequencies simultaneously. Better yet, the MQ-9B would be able to do this persistently for hours at a time, potentially indefinitely if the aircraft could be relieved when it needs to return for fuel, a capability which would have obvious applications in direct surface-to-surface maritime engagements, but would have even wider applicability in amphibious operations. A second potential application for the pod, beyond jamming radars, might be the jamming of incoming control signals, potentially allowing the MQ-9B to serve as a counter-drone platform. Drone warfare is evolving extremely quickly, particularly in the Russia-Ukraine war, but so far one of the most effective anti-drone techniques has been to sever the connection between a drone and its controller using jamming in electronic warfare. Though the utility of this technique waxes and wanes as each side develop their respective ECM and ECCM techniques, as long as an external signal is required to control the drone, they will remain vulnerable to jamming, and an adaptive jammer like the Angry Kitten may prove very effective in this role, at least until autonomy removes the need for a human operator altogether. For medium threat environments such as the Red Sea, this could be a very potent capability, at least in the medium term, until AI or other systems allow for fully autonomous operation of drones and current generation EW ceases to be an effective counter. A different electronic warfare pod has also been tested on the MQ-9, the Reaper Defense Electronic Support System / Scalable Open Architecture Reconnaissance, which we'll just call a SOAR pod. This pod is an adaptation of an older SOAR pod, which was primarily designed for electronic surveillance, with General Atomics, who manufacture both the pod and the drone, describing it as a broad-spectrum passive electronic support measure payload designed to collect and geolocate signals of interest from standoff ranges. In theory, the older pod would give the Reaper the ability to collect enough data about the battle space to support targeting and other decisions, while remaining far enough away from hostile forces to potentially survive. The updated pod takes that survivability even further by integrating a kind of stealth by electronic warfare, essentially giving the Reaper the ability to detect signals sent at it and respond with modified signals of its own, essentially allowing it to, in the words of one US Marine general, somewhat disappear off enemy radar. Obviously, this capability would be enormously useful in supporting the MQ-9B's role as a target designator for long-range strike. While not true stealth and therefore very unlikely to stand up to modern sensors at close ranges, even a limited ability to loiter undetected at some distance from a hostile surface asset for any length of time will make targeting those assets that much more viable, and in turn make the MQ-9 that much more useful. All that said, not every future ADF operation will be in highly contested airspace and require that level of stealth. Admittedly, the ever-lowering barriers to entry in the armed drone market, means that truly permissive airspace is probably a thing of the past in peer combat scenarios. However, it's easy to imagine scenarios like a modern-day East Timor campaign, where the ADF might find itself deployed into areas of significant risk, where air operations would be extremely valuable, but where hostile air power is either entirely absent or can be suppressed by other means. In Ukraine, that niche is partially filled by small, often modified commercial off-the-shelf drones, but that same conflict is also driving the kinds of improvement in anti-drone tech that could make those kinds of small, cheap, and non-EM hardened drones obsolete. This could potentially bring larger and more exquisite drones back into the fight in a way they really haven't been since those early days when Turkish TB2s were dominating the airspace. Alternatively, there are always likely to be low-cost, poorly or entirely undefended hostile assets at sea which could be valid targets for a drone strike. This might include small unmanned surface vehicles like the Australian-designed Bluebottle, or kamikaze drone boats like those we've seen in the Black Sea, or even the more conventional swarming small boats which have been considered a major threat in places like the Straits of Hormuz for decades now. The further away that these kind of targets can be engaged, the safer that Australia's naval assets will be. And all of these targets, which in their own way could really pose a significant risk to our surface vessels, lack a meaningful ability to defend themselves from the air at long ranges. And of course, if the ADF were to be tasked with interdicting hostile shipping as part of a far blockade strategy, operating the MQ-9B from the RAN's flat tops would at least give us the option to strike certain lightly defended vessels like oilers or supply ships at great distances. Airborne early warning is probably the most critical capability that proponents of Australian carrier aviation believe that the Navy is lacking today. Without eyes in the sky, Australia's surface assets, for all their modern radars and exquisite armaments, just can't see threats incoming beyond their radar horizon, which might optimistically reach out to 25 k's away. A high subsonic missile like a YJ-12 could potentially cover that distance in less than 30 seconds, making an intercept enormously difficult and risky. While an MQ-9B will never provide the full suite of capabilities that a dedicated AWACS can offer, simply providing overwatch above a task force with a synthetic aperture radar or an IRST to track incoming sea-skimming cruise missiles and extend the radar horizon could be a critical enabler of over-the-horizon targeting for the RAN, giving significantly more time for the ship and its crew to react to the missile than would be the case with no warning beyond what the ship's onboard sensors could provide. Additionally, there is limited scope for the MQ-9B to serve in an air-to-air role, chasing off certain kinds of hostile airborne assets, both manned and unmanned, which could allow a hostile kill chain to be maintained. Again, just as it's not a replacement for an AWACS, I'm not claiming that the MQ-9B might be a replacement for something like a Super Hornet or an F-35B, or that we'll see them fighting an outer air battle against J-15s anytime soon. But against something like a WZ-7 Soaring Dragon, a Sidewinder-equipped MQ-9B might be all you need to either take down or drive away the only asset capable of maintaining a target-grade lock on an Australian task force from some distance away, making it significantly harder to hit from very long ranges. So, with some of the potential capabilities of the type established, let's think about what it would take to get them operating off of Australia's LHDs. One major benefit of the short takeoff MQ-9B is that it could be implemented in RAN service with very minimal alteration of the Canberras. With the wing kit installed, assuming that it could actually live up to the manufacturer's claims, it shouldn't require any catapults or arresters to be installed, nor would the deck need to receive the heat treatment it would need to operate the F-35B. In terms of size, an MQ-9B is 12 meters long and has a 24-meter wingspan, though this is reduced materially in the STOL variant by the inclusion of folding wings. The Sea Guardian essentially has the footprint of a large helicopter like the MH-60 Romeo, which is 20 meters long with a rotor diameter of just over 16 meters. A Canberra-class LHD can carry up to 18 of these helicopters, though a more typical loadout is 8, so space should not be a problem. Moreover, with its wings folded, the MQ-9B will almost definitely fit on the Canberra's forward elevator, and likely on the aft elevator as well, making moving them around on board entirely achievable. The ships are already designed to operate helicopters, which share fuel with the MQ-9B, so most of what's required is likely already on board. In fact, going back to the Spanish design on which the Canberras are very closely based, they're designed to be aircraft carriers. So while potentially some specific fueling or other infrastructure may have been removed during their conversion to LHDs, any changes to bring them back are likely to be minimal. Effectively, if a small area were to be dedicated to storage for platform-specific munitions, subsystems, and spares, odds are these platforms could, at least theoretically, be operating off one of the Canberras today, basically, without modification. There are, of course, risks and challenges, as with any potential acquisition, especially for something like the STOL MQ-9, which isn't fully mature and operating out in the world. The most obvious challenge, or perhaps a better word would be uncertainty, is not whether the MQ-9Bs could actually operate off the Canberras, but whether they could do so with any kind of useful load. Certainly at 200 metres long, the Canberra significantly exceeds the minimum 100-metre launch length touted by the manufacturer, and the ski jump will probably also help to get the drones into the air. But what is less clear is how much of a payload limitation that such a short takeoff imposes. Could we, for example, expect the Sea Guardian to launch with a useful baseline loadout of a full tank of fuel, sea spray radar, IRST, and maybe a couple of sidewinders? Would it be able to launch with all of its theoretical maximum 40 A-type sonobuoys, or is that capacity limited to the conventional takeoff model? And if it can't take 40, how many can it lose while still adding sufficient utility to justify both its operational and acquisition costs? Even if we do assume that the short takeoff MQ-9B can take off with enough weight to fulfill at least some of the roles discussed above, it would likely leave a very small number of aircraft wearing an awful lot of hats. Let's consider what a deployed MQ-9B might look like. Assuming that a Canberra was not fully given over to drone operations, and MQ-9Bs didn't replace the significant majority of the vessel's helicopters, then a realistic component of drones might be assumed to be roughly 4 at standard loadout and maybe up to 8 at peak, half the typical air wing. If airborne early warning is assumed to be their primary role, then at least 1, or more realistically 2 given maintenance requirements, will always be tied up providing overwatch, leaving only between 2 and 6 other drones to undertake all of the other potential missions, be they strike, ASW, electronic warfare, long-range targeting, or anything else that the RAN or RAAF come up with for them to do at sea. Still undoubtedly a valuable capability, but one which would likely see a lot of expensive pods laying around aboard ship, taking up space and potentially requiring maintenance, without the airframes around to make regular use of them. And I really should emphasize that word, expensive. In many cases, much, maybe the majority of the cost of modern military equipment comes down to the high-end systems within that item. Sensors, weapons, computers, and other components are what give most advanced equipment its potency, but that potency doesn't come cheap. Each of these podded systems will likely cost millions over and above the $130 million baseline cost for the drone, making any MQ-9B actually flying with them an expensive and ultimately very vulnerable target. With any acquisition, military or otherwise, it's essential to consider alternatives, and acquiring the MQ-9B for the ADF would be no different. Even if you assume that a return to fixed-wing carrier aviation is on the RAN's priority list, an assumption it should be reiterated which isn't really backed up by anything at this point in time, the MQ-9B is not the only way that can happen, and it might not even be the best way. Ignoring for now aircraft like the Mojave, another General Atomics product which is very similar to the MQ-9B, 2 potential domestic alternatives stand out. The first is the MQ-28 Ghostbat, Australia's under development Loyal Wingman or CCA drone. Unlike the remotely piloted MQ-9, Ghostbat will be a fully autonomous aircraft capable of largely independent operations. There are a number of advantages to Ghostbat over the MQ-9B, beyond being a sovereign, domestically built Australian platform. To begin with, it's likely to be highly capable of providing overwatch, with its swappable nose cone sensors likely to include some very advanced radar and IRST capabilities. Additionally, with its much higher expected top speed versus the Sea Guardian and its low observable design, it's likely to be a far more capable air superiority platform as well, once later blocks are fully kitted out for air combat. The most obvious disadvantage of the MQ-28 is that even the baseline land-based Ghostbat is not currently fully developed or in service, let alone capable of operating at sea. Developing a carrier-capable version, particularly one which could operate from Australia's existing LHDs, would probably not be impossible, but nor would it be trivial. Additionally, while takeoff under some circumstances might plausibly be achievable using the LHD's ramps, landing would require the installation of arresting gear, and likely other modifications to the LHDs. This isn't impossible, obviously. Turkey plans to do essentially exactly this with their TCG Andalou, a near identical vessel to the Canberra class, but it does add cost, complexity, and time. Assuming that it's feasible in the first place, then weighing these downsides against the lower anticipated sticker price and domestic production of the MQ-28 will be necessary when choosing how to get RAN back into the fixed-wing game. The second potential domestic alternative is BAE Australia's Strix unmanned aircraft. BAE don't directly advertise the Strix as an MQ-9B competitor, but unsurprisingly, the marketing materials show a similar capability set, with littoral and maritime strike, air defense, presumably in the early warning role, opportunities in ASW and persistent ISR, target acquisition, and electronic warfare. Essentially, Strix seems to be able to do many of the things that the MQ-9B can do, just on a smaller scale given its apparently smaller payload, lower top speed, and shorter range. However, the aircraft are also smaller, likely logistically easier to manage on the LHDs than the Sea Guardians, and have a critical benefit of being manufactured domestically and at a much lower anticipated price point, taking them out of the exquisite realm and allowing more platforms on ship at any given time, and some ability to absorb losses with an active manufacturing line back home. One potential weakness relative to the MQ-9B is the absence of any kinetic air-to-air capability. Admittedly, the Sea Guardian's air-to-air chops are hardly spectacular either, but even its very limited capabilities might allow it to take out or scare off hostile drones of a comparable class to itself, potentially preventing a hostile kill chain from being maintained. Giving up on this capability would give up on one of the key benefits of bringing naval aviation back in the first place. Another advantage that the MQ-9B has over both alternatives is the long history of development that the aircraft and its predecessors have had. Developments like the SAWPod, the black hole electronic warfare capability that is supposed to hide the drone from hostile sensors, are the kind of benefits that operators get when buying platforms off the shelf. It's not impossible that we'd see these kind of innovative ideas from Australian-led and supported programs like Strix, far from it. But with fewer users over fewer years, there will just have been less man-hours and fewer dollars devoted to finding ways to improve the aircraft. And those hours and dollars generally do offer results, eventually. For what it's worth, I fully support both programs, and I hope that both Strix and the Ghostbat find their place in the ADF before too long. But personally, I don't think either is a fully valid replacement for the Sea Guardian. Before finishing the video, I wanted to briefly touch on potential operational employments of the drone in Australian service. So far, I've primarily focused on the capability of the MQ-9B itself, rather than detailing the practicality of its potential employment by the ADF. Ultimately, it will be this factor which determines the success or failure of the platform. If it can't be practically employed, then it's a failure, no matter how good it is on paper. There are three broad operational concepts for the short takeoff and landing MQ-9B in combat, beyond peacetime roles in maritime patrol, search and rescue, and similar things. The first is the one which we have spent the most time on in the video so far, operating as an alternative to more traditional carrier-based aviation from the RAN's Canberra-class LHDs. Given that we've already devoted a significant amount of time to this concept, I'll keep this section brief. While very different in its applications and operations, logistically the MQ-9B should be broadly comparable to operating other aircraft, specifically rotary-winged aircraft, from the LHDs. As discussed above, with wings folded, the MQ-9B has a footprint comparable to a large helicopter and should be able to use either of the Canberra's aircraft elevators. The flight deck is more than sufficient for the STOL MQ-9, per the manufacturer's claim that it only needs 100 meters to take off or land, and the vessel already includes storage space for munitions and a significant aviation fuel bunkerage. The Juan Carlos, which the Canberras are based on, carries 800 tons of JP5 aircraft fuel, the same fuel that powers both the MQ-9 and the more typical complement of the RAN, Seahawk helicopters. Some additional space would need to be allocated to the storage of sensor pods, spares, and MQ-9 specific weapons, but nothing that would be expected to materially hamper the operations of a vessel already designed to operate helicopters. Additionally, crew allocation would need to be allowed for maintainers and potentially pilots, though they wouldn't, strictly speaking, be required to operate from the carrier, though there probably would be advantages to doing so. Even if restricted to land-based operations, however, the MQ-9B still makes an enormous amount of sense in two other applications. The first is in defensive operations from Northern Australia. The 2024 DSR placed a strong emphasis on littoral operations for the Australian Army and gave them the further mission of long-range strike, particularly long-range anti-ship strikes. The intention is to deter the approach of any vessels too close to Australian shores by giving the Army the ability to reach out and touch them, with long-range armaments to do so currently being sought under Project Land 4100 Phase 2. The ability to use those weapons, however, is dependent on obtaining sufficient targeting data at useful ranges. At present, this targeting data could come from any number of airborne platforms, such as the MQ-4C Triton, the P-8 Poseidon, E-7 Wedgetail, or any of Australia's fighter aircraft. However, each of these assets is limited by their reliance on high-quality, well-maintained, static runways, the location of which will be well known to any potential hostile force. Defending and maintaining these runways against long-range attack is not guaranteed, and we could very well find many of them knocked out as part of a prelude to any naval attack, reducing their ability to offer targeting data to onshore shooters. The STOL MQ-9B, however, doesn't really suffer from this weakness. As was mentioned earlier, the baseline MQ-9 proved its dirt strip capabilities in 2023, and even if limited to bitumen, Northern Australia is littered with highways, many of which have enormous straight sections. No attacking force in the world could ever hope to take out every straight section of blacktop that exceeds 100 meters, which means that the RAAF could easily pre-flag dozens of potential austere operating bases on highways and ensure that a drone could always go up, no matter the kind of attack we might face. These rough and austere operating capabilities would also give the MQ-9B the potential of operating in its third combat application, forward deployment and offensive operations. Austere and short strip operations are going to be far more practical in the islands in Australia's northern approaches than establishing full-sized facilities capable of accepting more traditional aircraft. And since Australia hasn't chosen to purchase any STOL variant F-35Bs for these environments, there's really no other way with Australia's current inventory to offer any fixed-wing aviation capabilities to those forces at all. The STOL MQ-9B would change that. Sure, just like on the LHDs, it's not a full suite of capabilities. Given the choice, you'd rather have an F-35B every time, but properly prepared with electronic warfare pods to give it some survivability in contested air, even a single MQ-9B could offer extremely valuable ISR and strike capabilities to Australian troops against an adversary that, unless they happen to have an aircraft carrier nearby, might find themselves just as short on decent-sized aviation strips and the capabilities they enable. Okay, so I don't think I've done a particularly good job of keeping everyone in suspense regarding where my opinion comes down during this video, nor have I really tried to. I think that the MQ-9B, whether it's operating from rough strips in Northern Australia or Pacific Islands in our north, or off the deck of our Canberra-class LHDs, would be an enormously valuable addition to the ADF's order of battle over the next several decades. The upsides are fairly clear, with the most significant one being the ability to extend the sensor range for a surface fleet simply by means of altitude. Meanwhile, the downsides that are typically assumed for traditional carrier aviation from the Canberras, the need to extensively modify the ships, the inability to utilize them in their more traditional amphibious role, are largely avoided by the STOL MQ-9B. No significant modifications are expected to be required, and the Sea Guardian would be logistically comparable to a Seahawk helicopter in most of the ways that matter. More importantly, given its heritage as a platform designed for land war, there are plenty of ways that having an MQ-9 available would be more of a benefit than a cost in amphibious operations. All that said, I realise that the likelihood of the MQ-9B being acquired into Australian service and seeing these drones flying off Canberra-class ski jumps by 2030 is pretty low. Perhaps better than some other capabilities, given the ADF's history and their very near acquisition of the type. The approvals were all in place before it was cancelled at the last second. But given its absence from any recent official discussions or documents, including the 2024 Integrated Investment Program and the DSR, it's clearly not imminent. However, I still think that there's value in putting these ideas out into the ether, if only because of the geopolitical times we find ourselves in. The world is getting more uncertain, and our political leaders continue to tell us that we are entering a period of strategic risk that we haven't known, certainly since the Cold War and probably since the 1930s. If that is true, then Australia needs to do more to secure its defence, and we need to do it quickly. Recent events in America have only exacerbated that need and seen other nations around the world scramble to increase their defence spending. Surely Australia is feeling pressure to do the same, and our acquisition options may well open up markedly in the near future. It's great for the government to announce and implement the big ideas, like nuclear submarines and doubling the size of the surface fleet, things that will bolster our defence in the long term. But we also need to enhance the capabilities we have today, and we need to do it quickly and cheaply. And I don't think that there's a bigger enabler on the market today for this price range than the MQ-9B Sea Guardian. It should be a part of our security mix, even if it probably won't be.